Okay, so this is architecture explanation, kind of going in dive into how we're going to tackle setting up the kiosk. So one thing you have to understand when talking about the Raspberry Pi is that we have to implement a manager because we're doing something that isn't multi-threading. So in multi-threading, you can have 2 threads and each can operate independently doing operations on each, right? We don't want to deal with that because then we'd have to worry about how do you like connecting between here and syncing between them and making sure everything we're doing is thread safe. So we're going to avoid that. So the way we avoid that is by using a manager, and that means we only have 1 thread, and we need to manage this thread properly between whatever we want it to do, switching between whatever we need, right? So you can kind of think of the manager as you could think of it as a state diagram and it managing everything. So the first thing also to me, recap of the Raspberry Pi. So there's the Raspberry Pi, then you have the connection to the reader and writer, and then you have a tag, and then you have your phone device. So to start off, you need to be able to, since we're only worrying about this half, right? First thing you need to do is be in standby mode, right? And standby mode, you can think of that as just being in reader mode, just waiting for this to come close enough for it to be read. So you'd have like a reader mode here. And then after you've read it, then what we need to do is we need to verify that whatever's on that tag is from us. So we need to certify that the signature is created by the club, right? So that would go to a verification mode, right? After that, then you have to go to some logic. I'd call it a logic mode, right? And this needs to check that this tag has not been given a point today, right? That's the system we're going to go with. If the tag has been given a point, also some background into the tag itself. So you can think of it in sections, right? This is like the permanent bits at the top of the tag that can't be modified by us, right? Then we have an NDEF header. And you can just think of this as like the beginning of a letter, and it's telling the reader, hey, what's after is going to be data, okay? And then you have your data, and then you have a little NDEF closer. It's like barely a byte, or like it's around like 2 or 3 bytes, I believe. Then this data, what needs to be on here, right? We need to have the name, the date it was last signed, name, date, and a signature, right? Oh, and points. Let's not forget about that. So the points, signature. You can think about this half as like data, and this is just verification, like verification data. Okay, so at the reader step, it just reads all of everything that's within the tag, right? Then it sends that to the verifier. The verifier, what it's doing is it takes the data, so to say, has this data or whatever, it hashes this, and then now you have hashed data, right? Now you have the signature part, which is signature, and then in theory, whenever you apply the public key, what will happen is this should spit out the same thing, hash data, if you apply the public key. Okay, and then we check if these two are matched, and that's the whole process of verification, right? If you want to go run down how we sign things, all we have to do to sign something is to take the data, right? We hash it. Now we have the hash data. And then now we're applying the private key. And then this will spit out a signature, right? The public key and private key are mathematically linked, and just think of them as functions that reverse each other. It's just that without the other one, you can't reverse what the other one has done, right? From the original state. That's all you need. It can go way beyond that in explaining how it actually works, but that's all you need to understand how this is working, right? This proves, since these two numbers are mathematically linked, that only someone with this could have produced this, right? So the public key is just used to verify that this is true, right? So now that you've done verification, now you go to the logic, right? You can kind of think of it as it's just checking. It's like if, and then today is not equal to, right? To last date signed, like the date signed. Then what we want to do is add a point, right? And then you can think of it as an else statement in that, hey, if it's already been signed today, we don't want to give them another point because they've just gotten, you can say they just got a point today. So now this needs to kick it back to the reader mode, right? Whenever it fails. And also at the same point in verification. If it fails verification, then we know this tag is not from us. We don't need to do anything with it, right? We just send it back to the reader mode, right? After this logic step, right, return to start. After this logic step, then you need to go into signing the new tag, so the new data we just created. So you've added a point and you've changed this data that's in the tag. So now we have to create a new signature for it. So this is going to do the signature right here. Just call it sign. It signs this tag, the new tag you've created. That's kind of being passed here between the logic and the signature, right? Then after it signs it, so it does this process, right? It hashes it, then it applies the private key, and now you have a signature, and it just puts it onto the bottom. The reason why you can't use the same hash is because even if you change one bit, a hash value will change drastically just by one bit. And we need that to be the case so that we can't have, it's called number field manipulation, kind of, right? Imagine you have two data sets, right? And then they produce the same hash value when you hash them. That's a problem, right? Or they produce the same value when you hash them. And that can create some complications, right? So they could possibly use the other signature that we've just created for this data to use for this data, right? And that puts a vulnerability in the system. So now after you've signed it, it's pretty easy. Now you always can tell that you need to write it. So you pass it to the writer, and this needs to check what's going on here. It gets sent to the tag again. Now it's with the new signature that's on the bottom. It writes it to the tag. You could probably think of this also that it has to manage some error checking, so it has to read it twice. You write once, then you check, then you read it at least once, just to make sure that you've written it properly and there's no kind of issue. Like if they pull the tag away from the reader, then it'll throw out an error, but if it's not written properly, then you need to rewrite it again properly, right? Now you have the final mode that is probably the most important mode, which is what we use to start this process, right? This is automatic. All of this is automatic, right? That you don't like. There's no need for human input. It's just running constantly doing this, right? What we need now is to be able to produce tags. So the way we produce tags is we need to have like a manual mode, right? And manual mode just needs to ask for one thing, right? At the current moment, maybe if the details of the tag change, then we need to ask for more. It's like maybe an email if we want to do that later. But at the current moment, all we need to ask is for a name from the user. And then it'll generate the date is today, right? The last date assigned is today. And the points are 0. So you're starting at 0, right? Maybe later we can do something that it'll start at earlier, more points or something. But you pass this into the sign leaping through all the reading, verification, and logic, and just signing it. Now that once it's signed, it does this, and it spits it out onto the next tag that we put in front of it, right? It's kind of a manual note. And I think that's everything that needs to be explained for this Raspberry Pi sign. Let me see. In-depth signature verification. Yes, this should be everything. If you have any questions, feel free to add those later. Thank you.